Causation and experiments. First, we start off with some terminology. Explanatory variables are also called factors when dealing with experiments. Different values of the explanatory variable are called treatments. And you'll see treatments denoted as TTT often. The group of participants in which no treatment is given is the control group. And participants in an experiment are sometimes called subjects. So just like when dealing with observational studies, we want to develop ways to eliminate, ideally, the lurking variables so that subjects differ only by the treatment. That is the ideal for us to be able to have evidence of causation. Okay, so one way that we can minimize lurking variables is by using a randomized controlled experiment. So in this type of design, subjects are randomly assigned by researchers to either the treatment or control group. So by randomly assigning the participants, the group should not differ significantly. Secondly, the inclusion of a control group gives us a way to see if there does seem to be a difference between people who have received a treatment and people who have not received a treatment. So although ideally this sounds good, there are some instances where having a control group may be unethical. So can you think of a way or a study in which a control group may not be ethical? Well, I can give you an example. Suppose the participants of a study had cancer. The researchers offer a free experimental treatment to determine its effectiveness. So half of the participants receive the treatment, and then the other half are in the control group and receive no treatment. This can be looked at as unethical because there are half of these participants with cancer, they need treatment, but half of them are not receiving it. Another example is one that I used in a previous module, and that's with the Tuskegee Airmen. However, in this study, all of the participants were in a control group unbeknownst to them. And just to review, that was a study in which the effects of untreated syphilis was being examined, but the participants did not know that they were not receiving medical treatment. So this is an example of a study that's unethical. Going on to the next page. Looking at blind and double-blind experiments. So that participants do not know whether they're receiving a treatment, a placebo is used. So if it involves a treatment that's a pill, half the participants would be getting the real pill. The other half would be given what's called a placebo, and often it's a sugar pill. To control for the experimenter effect, a double-blind study might be used. So double-blind means that both the researcher and the participant do not know which participants are receiving the treatment. So the experimenter effect could be, for example, if a pharmaceutical company is testing the effectiveness of a certain drug and say they've spent a lot of money on this drug, so they're hoping that it works. Well, the experimenter working for the company might be have a vested interest in it being an effective treatment. So to control for that experimenter effect where they might be looking for evidence of the treatment being effective that may not be there or may not be as strong as they would like it to be, a double-blind study would be a good way to go. So the ideal design would be a randomized, controlled, double-blind experiment. So the participants are randomly assigned to receiving a treatment or not, receiving the placebo. We'd have a control group, and neither the participants nor the researchers would know who is in which group. Okay, so some of the issues, though, that can come up with experiments. First, there's something called the Hawthorne effect. This is when people behave differently when they're not in their natural surroundings. So, for example, if you have somebody participating in a weight loss study and you're examining what they normally eat on a daily basis, if someone knows that someone is going to be evaluating their eating habits, they may eat differently knowing that someone is observing them. So this is the Hawthorne effect. Non-compliance can be an issue with experiments. This is when people may not follow the treatment to which they've been assigned. Also, there could be ethical issues with experiments. Some treatments might be unethical. The use of a control group may not be reasonable, or it could be impractical or impossible. So the next example, a researcher wants to determine if taking calcium tablets helps to reduce cavities. Participants are recruited and divided into two groups. The first group is given calcium tablets to take regularly, and the second group is given a placebo that looks like the calcium tablets to take regularly. Question A, what would have to be true for this to be a double-blind experiment? So remember, for something to be a double-blind experiment, that means neither the researchers nor the participants know who has been given a placebo or who has been given the actual calcium tablets. Question B. Suppose the researchers find that the group given calcium tablets overall had an increase in the number of cavities, while the group with the placebo had a decrease in the number of cavities. Does this mean that taking calcium tablets does not reduce the number of cavities? Explain. Well, I think that you've had enough caution at this point to know that we cannot assume that means that taking calcium does not reduce the number of cavities. There's still lurking variables that are present that we're not controlled for. There may be lurking variables present. For example, perhaps more people in the calcium group had bad dental hygiene to start with. For example, more people in the calcium group may have had bad dental hygiene to start with. Maybe a lot of the people in that survey, in that group, a disproportionate amount, may not have brushed their teeth regularly or as often. Or we could have that there may have been some non-compliance. Perhaps the participants were not taking the calcium pills regularly, which made them no different from the group that were taking the placebo. In other words, maybe they did not take the calcium regularly. So unfortunately, most experiments are not foolproof. Most studies are not foolproof. So you report the results of your study, but you cannot say that your explanatory variable necessarily caused the response variable. At best, there's evidence that there may be a relationship. Well, so far we've been looking at experiments that have one explanatory variable, but it's possible that you can have more than one. And if this is the case, then we would want the randomization to occur twice. First, we'd want to randomize the selection of participants, ideally. And then secondly, we'd randomly assign these participants to the multiple treatment groups that we have. Okay, so although this would be the ideal, realistically, most participants come from a volunteer sample or a convenience sample. Okay, so let's look at this example. A researcher is interested in determining if eating breakfast along with following a weight loss program resulted in quicker weight loss. Suppose subjects are randomly assigned to the breakfast or no breakfast groups and also assigned to goal gym or aerobic video. So how many treatment groups result from this study design? Well, we can make a table to help us visualize it. So we see that we're dealing with two factors here. One is whether participants eat breakfast or they don't eat breakfast. And then within those groups, we're going to have people that go to Gold Gym or people that are doing the video. So we see that the number of treatment groups we end up with is a total of 4. So the way that we can compute this without having to write a table is you just take the number of treatments in each factor and you multiply them together. And we see we have a total of 4 treatment groups. Okay, what is the explanatory variable in this study? Well, we actually have 2. The first one is whether they eat breakfast. So whether breakfast is eaten, and also the exercise type. Let's just say that. And the exercise type being the gym or watching the video. What is the response variable? What are these explanatory variables being used to try to predict? Weight loss. Next, we want to look at some modifications to randomization. One way that we can try to control for lurking variables without using randomization is by using something called blocking. With blocking, we divide subjects into similar groups of individuals with respect to outside lurking variables. So we may use blocks of gender, male and female. We could do age. There are lots of different types of blockings that you can do. One type of blocking that's commonly used is a matched pair design. So matched pairs is a type of blocking in which similar individuals are compared to each other. And probably the most ideal type of matched pair would be using twins in a study, where one twin is given a certain treatment and the other twin is given a different treatment. Okay, example. A researcher wants to determine if regular praise from one's boss affects the productivity of the employee. Name two possible blocks that the researchers could use to help control for lurking variables. Okay. So blocks are often going to be the lurking variables that you think may affect the outcome of your study. Okay, so one block that could be used is the achievement of the employee. So you might have a group of high achievers and a group of low achievers, and that could be based on their evaluation. So let's say those with high evaluations, and that would have to be quantified somehow, versus employees that had low evaluations. So within those blocks, we will want to see if praise from the boss would affect their productivity. What's another block that might be important? It might be the length of time at the company. So we might want to look at new employees getting praise versus veteran employees. So there are lots of different ways it can be done. This is just an example of two that I thought of. Okay, lastly, we want to talk about sample surveys, which is a very popular and common way to produce data. So it's important to try to make the best survey possible so that you can have some valuable results. So when writing survey questions, you can have closed questions or you can have open questions. So an example of a closed question would be, is your favorite food pizza or ice cream? Well, clearly that's not a good question, because what if someone's favorite food is neither of those two things? So an open question that would be better is, what is your favorite food? Okay. Something else that would affect a good survey question are the answer choices, and you want to make sure that they're not biased. So for example, let's say that you were asked, how would you rate your mentor? Excellent, good, average, or needs improvement? Well, there's an issue with the scale used here because it's skewed positively, right? You have two that are positive. The average isn't bad. Needs improvement is the only negative one. Okay, so the answer choices are biased because they're skewed to be positive. So that's something to be cognizant of when making your survey questions and answer choices. Okay, and lastly, randomized responses. This is a way to try to get more reliable results from a survey if you're asking sensitive questions. So this is an example of when a randomized response may be helpful. Suppose a researcher wants to determine the percentage of the population who have cheated on a final exam in college. A sample of 1,000 college graduates is obtained. The participants are all told to flip a coin in private, and if they get heads, then they should answer that they did cheat on the final exam, whether or not they did. That's what their instructions will be. If they get tails, that should read, because we don't want everybody's not going to get heads. If they get tails, then they should tell the researcher the truth. So since the researchers, this will be assuming that it's a blind study, the researchers don't know what the result of the coin toss is, the participants can tell the truth knowing that the researcher will not know whether it's true or not. So that way they don't have to worry about that judgment. So this would be an example of a randomized response.